March 2, 2011. Inside the Yerba Buena Center for the Arts, a visibly frail Steve Jobs, currently on medical leave for pancreatic cancer, unexpectedly stepped onto the stage. He was there to reveal the iPad 2. The defining feature of the presentation was the device's physical profile, a chassis shaved down to exactly 8.8 millimeters thick. That was a massive 33% reduction from the first generation. To the audience, Jobs described the engineering of the device as magical. He proudly announced that this perfectly unburdened slab of glass and metal marked the arrival of the post-PC world. Toward the end of the presentation, he laid out his core philosophy. It's technology married with liberal arts, married with the humanities, he said, that yields us the result that makes our hearts sing. This rhetoric positioned the device as a pure manifestation of thought, conjured directly by brilliant minds in California. But as Jobs himself had noted years earlier, a great idea is only a fraction of a product. The rest requires an immense, unseen amount of physical craftsmanship to execute. The physical universe demands an accounting. If you delete 33% of an aluminum shell's thickness to achieve a perfectly minimalist design, that solid physical mass doesn't simply disappear. It has to physically go somewhere. That displaced mass went halfway across the world, to the Foxconn A5 manufacturing plant in Chengdu, China. Turning a rough block of industrial aluminum into a flawless, mirror-edged casing requires extreme mechanical friction. The metal has to be relentlessly ground down and buffed against rapidly spinning polishing wheels. When a designer erases a millimeter of thickness in CAD software, that action translates directly into thousands of microscopic aluminum particles. Over months of production, that trimmed 33% accumulated into tons of highly combustible metal dust with a massive reactive surface area. Inside the A5 plant's polishing workshop, this ultra-fine dust had nowhere to go. It remained perpetually suspended in the air of an entirely enclosed, poorly ventilated room. To produce millions of minimalist devices, an immense volume of physical chaos was forcefully compressed into one sealed room. By the evening of May 20, 2011, the environment inside that room had become critical. The timeline narrows to a 12-minute window between 7:18 and 7:30 p.m. Unseen to the workers, the concentration of aluminum dust in the air had silently crossed the lower explosive limit. This is the exact mathematical threshold where a suspended powder becomes a highly reactive explosive. At that moment, a massive shift change was underway. Hundreds of young workers packed tightly into the workshop, inadvertently agitating the thick air. In an environment past the explosive limit, ignition requires almost zero energy. It could be a faulty motor, a short circuit, or simply a worker removing a static suit and releasing a tiny spark. Given the variables in play, a reaction was a mathematical certainty. The only unknown was the exact minute the equation would solve itself. A single spark found the highly combustible dust. This triggered a blinding, supersonic chain reaction oxidation of the suspended aluminum. A 1,000-degree fireball ripped through the polishing workshop. The force of the blast was severe enough to crack the reinforced concrete walls on the second, third, and fourth floors of the massive building. 3 young workers were killed. 15 others survived with severe, disfiguring burns across their bodies. 2 months prior, on that stage in California, the prevailing narrative was that blending technology with the humanities creates a product that makes the heart sing. Inside the Chengdu plant, the half-finished aluminum shells, machined to be perfectly light and thin, were instantly twisted by the shockwave into high-velocity shrapnel, slicing through the workers in their path. The pristine glass displays showcased to the world stood in stark contrast to the shattered factory windows, the thick, toxic smoke, and the horrific burns suffered by the people assembling them. The weightless minimalism of modern technology carries a heavy physical mass. The perfectly smooth edges you hold in your hand are paid for by immense industrial friction, and in May of 2011, by the lives of the invisible labor force required to make the math work.